Hi, my name is Grzegorz. I'm here to talk about how to have some... I want to share two questions basically with you. Two questions that help us in multiple occasions to have better decision making and to choose better solutions to the problems that we are facing. So let's start with, of course, the examples. And first example will be about how different problem definition can help us find a better solution to our problem. So my example for you is that this year I've been tackled at work of building a voice channel support for AI agent. I'm working in a company that builds AI agent platform, and apart from supporting chats and emails and so on, I've been tackled of, add a possibility so that a customer can make a real phone call and talk to the AI agent. And like having a step forward in time. We've delivered it, of course, but in the meantime, after like first version of the product, we got feedback from our customers saying, you know what, latency is like too big. Like customers cannot wait so long waiting for the AI agent to answer their question. You must do something about it, and please like decrease the latency. And of course, what the team of great engineers did at the start, like they tackled all the difficulties of technical difficulties, how to decrease the latency. But unfortunately, we came to two constraints that we couldn't really very fast tackle. One constraint is that modern services and providers that often build the voice support for AI agents don't even provide the SLA for their response times. Think about LLMs that we are using on the daily basis. Think about speech-to-text and text-to-speech algorithms. Those things don't, on either provider, then don't provide how, what's the response times of their service. And the other thing, like our platform has been built by over several years, and it's not has been built for latency. Actually, it has been built for throughput. And in my mind, it's a bit as if we had a great army of services that are like rats, and they go in a hole under the ground in the city, and they are great in doing it, penetrating the city. But then they have another task to do, and they need to go outside on the ground and go through a maze, right? And they need to do it as fast as possible. But actually, of course, they can do it, but they won't be as performant if we would have like a bird or an owl that just starts, see the exit, and lands there, right? So those two constraints makes a little bit of a constraint that we couldn't really go through. And if we think about latency, the problem that clients came to us, latency is a kind of a problem that is an output problem, right? There's only a single solution that we can apply to this, and it is to decrease the latency. There are no other ways to solve this problem. And the first question that I want to share with you today is, why is it a problem? When we ask this question, it opens up multiple new opportunities of a solution that we can apply for a given problem. And also some supporting questions that might come in handy when we are stuck with a better problem understanding and finding more than one solution. So for example, is this a problem or only a symptom of some other aspects of my problem? Or what are we trying actually to achieve? So trying to state the problem or the solution more in terms of outcome rather than the output. And the last thing, can we actually find a different solution to this problem? Very often, I don't know how about your experience, but in my experience, people come and they actually share their own solution instead of sharing what problem they have. And then there's something like a solution in disguise, right? Then it's very good to ask, can we find different solutions to this problem? Because if we cannot, we are actually already dealing with a solution. So if somebody gives you a solution, you cannot find another solution to their solution. So what we did, our latency problem is the output, but actually if we come to the outcome that we can define is how to decrease the caller's frustration. Because in reality, users don't really care how fast the AI agent will respond. They will say they do, but it's not the real point. They don't want to get frustrated. They don't want the uncertainty waiting for AI agent to answer their call. And they want to know that they have been heard and the answer is coming. like with real human, right? And when thinking about this problem this way, we can actually find multiple new solutions to the problem stated this way. So for example, how to minimize coding frustrations. When we hit the wall of the latency that we can achieve from the constraints that I mentioned, we could, for example, add a mechanism saying, let me check, like the same as the human person would do in real life, right? We can add a beep mechanism. This is something that you can be aware of when you're, for example, in a car and you're starting the navigation. There's sometimes a beep sound that says beep, and it means that, you have been heard and we are starting to process your message. Or, for example, we've been experimenting with background noises, because it turns out that for customers, what is troubling is the silence, this uncomfortable silence that we don't like when you're waiting for 5-6 seconds to the AI agent. So if we put a background noises, like even light, and you hear something happening in the background, it makes you being calm and waiting much smoother for the answer of AI agent. So starting with this question, why is it a problem? It helps you define more variety of the solution, opens up your mind, and actually have more chances to get the solution right in the end. So that's going to be the first example. And the second example will be about possibility to reverting the decisions. And now let's take a step back this year, and we've been tackled with the team to build the voice support for AI agent. And to start talking about this, I need to support myself with this little chart. This is a chart that shows that any decision that we make in life or at work can be put somewhere on this matrix in one of the 4 quadrants. So the axes are if the decision is consequential, big consequences, low consequences, or is it reversible, or easy to revert, or hard to revert decision. And basically this matrix shows us that whenever we go into the lower bottom, so the decision you have to make has it's not consequential, you just decide now and act. Like if you got it wrong, you just will revert it, nothing happens wrong, you will think of something else. If your decision to make is consequential, but it's easy to revert or possible to revert, you can analyze the options that you have and act quickly. Because if you got it wrong, you will just find your other solution and try it next time, right? Iterate, find what works for you. And there is the last quadrant when you have consequential decisions, so big consequences, and hard to revert decision. And why does it matter? Those are the hardest one, right? Because those are something that we, for example, from my technical perspective, we design an architecture and then it sticks for us for like 10 years of the company, right? And why this matters? Because when we go to the upper right corner, the painful consequences are rising if we got our decision wrong. And it's not often that our decision is wrong at the time, right? But especially in the modern era where everything is moving so fast, especially in the landscape of AI and LLMs and so on, and it might seem that your decision right now is fine, but in half a year or 1 year later, new solutions pop up and you need to be fast and flexible enough to switch to them to not stay behind. So this can be similar or sound similar to something that is called one-door decision or two-door decision, but this has a small downside, I would say, that it's either this or this. And when you see on the matrix, you can put your decision anywhere on the matrix, so you can move it left and right. And this is the second part of what I would like to talk about today. So when we are in the upper right, so careful analysis, we are good at this, right? We know what to do to make better decisions that are hard. Because even on any problem that we can state, we can probably hire an expert to gain knowledge about a new domain that we need to tackle. We can run a POC with our customer to see if this actually has any chance of working, right? Or, for example, create a detailed architecture decision record where we compare multiple aspects of different solutions and see which one will be the best for us. So this is okay, but all those actions cost us effort, but it doesn't reduce the consequences. Consequences stay the same, and it doesn't return or decreases the possibility of reverting the decision, right? It doesn't make it simpler to revert the decision. And today I would like to propose you with a second question. So how to make it easier to actually revert your decision? It's possible, and it's a powerful question that we can ask on almost any problem that we actually have to solve and any decision that we need to make. So we will try to move from careful analysis, decisions that require careful analysis, to decisions that we can act on quickly after a small analysis. So actually, what gives us easier to revert decisions? There are several aspects that we can do before I jump into the examples of how we approach it. It reduces the risk, because whenever you have easier to revert your decision, let's say you got it wrong, it makes you feel, okay, let's move and let's decide something else, right? Let's choose our different solution. That's fine. It encourages you to build a built-in flexibility into your solution. It's especially important, for example, in my company, where we know that the rapid evolvement of AI landscape is such fast that in half a year, for example, there might be a new model, new provider, new service that we need to incorporate very fast into our solution, or we'll stay behind, right? Because it will be simply a new state of the art in a given point of time. And it also helps making decisions in seconds, especially when you learn that, and when you teach the whole company to make decisions based on this on every call that they need to, for example, compare two different solutions. So yeah, let's jump into it. As I said, no experience in doing that, high uncertainty when we had to start this project. And what we did actually is we took some small steps to make it easier to revert and build more flexibility into the solution. So first of all, run a POC, probably a simple one that we can all think of, right? Another thing that is very important, we decided, okay, we need to put a little bit more effort, but we cannot have a vendor lock-in on any part of the system that we are working on. And third example, when we decide we need to create a whole new architecture and infrastructure to supporting voice solution, because it's completely different than anything else that we've been working in so far. We decided to enable us in the future to switch any internal components without affecting our clients. And this way, we'll be able to change or replace or play around, play A/B tests or split traffic however we want, without asking clients to do any operational and infrastructure part on their side. And also, those are the two examples that I have from very hands-on meeting of engineering teams, when we, for example, had two solutions that are being considered, and both are equally good. There are no positives or downsides compared from them, or they have different ones, but we cannot decide which one is better actually. And asking this question, which one is easier to revert into the other one, it immediately pops, yeah, this one is much easier to revert into the other one. This one has more constraints that imposes on us. So in 30 seconds from a decision that we cannot make, we made a decision, yeah, this is the better way that we can go with. Another example, so there are two solutions that we consider, and one is obviously better, but more complex, more complicated. This is actually about putting the infrastructure for the voice AI agent support into action. And one is much better, more complex, will take us more time to deliver, etc. The other one, we know that there are constraints and limitations. For example, seeing the data of how many customers we onboard into the solution, we see that it will last for about 1 year, right? So what to choose? Do we invest now, knowing that in a 1 year time we need to switch to the other solution and it's a waste of time? Or do we go with the simple solution, faster time to market, we can go in and onboard customers faster? And one question that we can ask is, okay, but what we need to know now to make this simpler solution easier to revert in the future into the much more complex solution? And asking this question helps us produce a list of things, and one of those things is, for example, to isolate one specific component of this infrastructure that is facing the customers, so that we are free to change anything internal when we decide to move from simple to advanced and complex architecture. So yeah, this question is this one. So just for this scope of the presentation, I just wanted to leave you with two questions that I find very powerful and useful on a daily basis, both at work and in life, because in life we also tackle a lot of decisions and problems. And why is that a problem, and how to make it easier to revert this decision helps in a very way. I hope you will enjoy those questions too. Thanks a lot.
Thank you very much. You can ask questions on Slido, so please do this. I have one question. The toughest decision that you reverted?
That decision that we reverted? Yeah, so I'm working currently in a startup that started and being developed by young developers, and the architecture wasn't prepared for a rapid growth of the startup, as you can imagine. And then we had a big decision, like 2 years ago, that we need to build and restructure the architecture to support the new way, or like simplify a lot of stuff. And we went this way. We are like halfway through the migration and so on. But right now, when we introduce the voice AI agent, and we know that there are some specific models and services that don't really operate in the same way that we can incorporate into this architecture that we designed, we didn't even know that we'll need it. We are actually like making we don't know if we're gonna be going further. We'll most likely revert it one more time and go with the decision that we simplify it much more. Because otherwise we won't be able to, for example, incorporate real-time voice models into our solutions. So yeah, it was a consequential, the first architecture was consequential and hard to revert decision, and now we'll probably revert it anyway. And yeah, it's painful.
Life,
yeah.
Thank you very much.